Hello everyone, welcome back to our channel, The Absolute Chemistry. I'm Abhisek. As you all know that we have already discussed the formulas or everything of that Arrhenius equation. This video is mainly based on the numericals, some PYQs. I have tried to get some different types of questions, okay, and I want to just show you that how you should approach these questions, okay. Then you can do any questions, I think. Okay, so these are all PYQ questions and all those years I also mentioned. So let me just start. I have got some questions. These are two questions. First two questions we will be doing. Okay, let me start. So in the first question, it is asking, what is he asking? Let me just take a bigger one. Yeah. What is he asking us? Yeah. In respect of the equation, so he has already given us the Arrhenius equation. Okay, so you don't have to think about it. In chemical kinetics, which one of the following statement is correct? Okay. So I have already told you that K equal to A e to the power minus EA upon RT. Which of the following is the correct one? Okay, it is saying that A is adsorption factor, EA is energy of activation, R is redox constant, K is equilibrium constant. Okay, so we have to know all these terms. Okay, we have to know all these terminologies. So what are these terminologies? K is nothing but the rate constant. Okay, see, uh, in equilibrium, K is nothing but equilibrium constant. But in chemical kinetics, it has mentioned properly that in chemical kinetics. So you have to be very careful because you might get confused and you might because see, in these questions, silly mistakes happen. In these questions only. So you have to be very careful. So K is in chemical kinetics, it is rate constant. A is nothing but it is a pre-exponential factor. Pre-exponential factor, or it is also known as frequency factor. Okay, it is also known as frequency factor. Now what is EA? EA is nothing but activation energy. It is nothing but activation energy. Now what is R? R is ideal gas constant. Ideal gas constant, unit was joule per mole Kelvin. And what is T? T is nothing but temperature in Kelvin. Temperature in Kelvin. So now let's check the options. What are the options? A is absorption factor. Is it? No, it's not. R is redox constant. Is it? No, it's universal gas constant. K is equilibrium constant. No, because it is rate constant in chemical kinetics. So the only option that is correct is EA is energy of activation. That is the activation energy. So this is the correct answer. Okay. So now let's move on to the second question. Okay. If you have any doubt in any question, you can mail also. I have given my mail ID. You can ask in the comment and also you can send a mail. I'll definitely reply. Okay. So let's go to the next question. Okay. What is the next question? I have taken this question little intentionally so that I can explain the activation energy properly. Okay. Rate of reaction can be expressed by Arrhenius equation. This in this equation, E represents what does that E represents? We all know that E represents activation energy. We all know that E represents activation energy, but what are the options? In option, it is not mentioned that activation energy. It has given the options like the energy above which all the colliding molecules will react, the energy below which colliding molecules will not react, the total energy of the reacting molecules at a temperature T, the fraction of molecules with energy greater than activation energy of the reaction. So it is based on what is actually the significance of activation energy. What is the significance of activation energy? This question is based on that. See, according to that activator complex theory, what happens? Let's draw the energy profile diagram. It didn't. That's fine. Let's do it. Suppose this is the reactor. Okay, this is the potential energy of the reactor, and this is when reaction is proceeding. Okay. Suppose this is the reactant and this is the product, energy of the product. And this is the path it is following, the energy path it is following. Okay, this is the reactant, this is the product. Alright, just one second. Uh, just one second. Yeah, see, as you all know that this is the reactant and this is the product. See, this is the maximum energy level. Okay, this is the maximum energy a point while the reaction is taking place. So this point is known as the transition state point. Okay, what is that transition state? A reaction always proceeds through a transition state. Okay, this is an activated complex. Transition state is an activated complex. What happens when the reactant molecules will collide with each other, and that collision should be effective collisions. Okay, and if it is not effective, then the reaction won't take place. They won't form the product. Collisions always occur, but it has to be effective one. Then only the reaction may occur. May occur. Okay, the reaction may occur. So, uh, to form the product, this much energy, because see, this was the energy level of the reactor. Okay, this is the maximum energy it has to attempt to form the product. So this energy gap, this is known as the activation energy. That means you have to increase the energy of the reactant up to this level so that it can reach to the transition state, that is the activated complex here. This is the activated complex, then so that it can proceed to the product. If you won't be able to reach this point, then definitely the reaction will not occur. If you are only reaching to this point, the reaction will not occur at all, because this is the maximum point you have to reach. So this is the activation energy. Okay, so what is the significance of this activation energy? The energy above which all the colliding molecules will react. See, what happens? Suppose above the activation energy, all the collisions, okay, they have the potential to be known as effective collisions. What does that mean? That means they can form the product, but it's not always the case that all the collisions will lead to the product formation. It's not true. But one thing is true, is that the energy below which colliding molecules will not react. If the collision will always take place, okay, but if it is not reaching to the activation energy, then there is no chance of forming a product. Once it reaches the activation energy point, then it might form a product, otherwise it will not. Okay, so which one will be the correct answer? Here the correct answer will be second one. Okay, second option. Be very careful, because most of the students might go for this one. Okay, because this they have kept it in the first option only because of that, so that you will be impatient and you will take the first option and you will get a negative marking. So read all the four options. Okay, in this kind of questions, try to read all the four options. Okay, so now let's go to the next set of questions. Let me come back. So now we will start doing the numericals. Okay, these are numerical based questions, so we will do it now. So what is he asking? Solution for this one. Okay, I'm doing the solution for this one. Let me choose a, yeah, this is the point. Yeah, yeah. Solution. Okay, for this one, this question I am doing it. The question is, the rate of a reaction doubles. Okay, when its temperature changes from 300 Kelvin to 310 Kelvin. Activation energy of such a reaction will be how much? What is the activation energy? It is asking that what is the activation energy of this reaction. It has given some conditions. Okay, and this is the, it has given some values also, the the gas constant and the value of log 2. So what is it asking? It's asking that uh, what is the temperature? We are increasing the temperature from T1 to T2. So T1 is nothing but 300 Kelvin, T2 is nothing but 310 Kelvin. Okay, 310 Kelvin. And what is he saying? So the rate constant will move to K1 to K2, and it is saying that the rate of the reaction doubles. So if the rate of the reaction doubles, that means the rate constant doubles. Okay, so that means the K2 is nothing but 2K1. Alright, doubled, because it doubled. So just directly put the equation, nothing is there. What is it? Ln, sorry, EA upon RT, T is not there, excuse me, T2 minus T1 by T1, T2. Alright, so just put the formula, put the values now. So ln K2 means that is 2K1 upon K1, and you all know that if I am going to do it as logarithm, what will happen? Nothing will happen, only this is, you have to multiply 2.303. The value of R is given 8.314, T2 is 310, T1 is 300, 300 into 310. Okay, so this will be equal to nothing but log 2 is equal to this much. Alright, now it's your job to do the calculation. Now it's your job. I'm not going to do this calculation because I'm not going to write that exam. You have to do it, and I'm also telling you the answer. What was the answer? Yeah, this one is the answer. Okay, so try to solve it. Okay, now try to solve it, because just put the value of log 2 here. Okay, solve this one, and just find out EA. You have to just find out EA now. Okay, I have nothing more to do here. I have already given you the format that how you have to. The most important thing was this point only. Okay, this was the important point. They wanted to check you this one actually. Then you put the formula in and you got the answer. Simple as that. So this question is also done. Now we will go to the second question. Next question. I have already solved it. That question I have already, the next question also I have already solved it. That particular graph. Okay. So what is the question? The question is the temperature dependence of a rate constant is this the Arrhenius equation. Okay. It is asking that activation energy of the reaction can be calculated by plotting which graph? By plotting which graph? So you all know that K is equal to AE, or and he has also given it. He has also given it. So ln K equal to ln A minus E upon R 1 by T. We have already drawn this graph. Y, C, you can do this now. M, X. Okay. So in Y axis we were taking ln K. In X axis we were taking 1 by T. So this was the graph we found it. The intercept was this one, and the slope is nothing but minus A upon R. So how can you determine the activation energy from here? Because when you plot the graph, you will definitely get a slope. You can definitely get a slope like this. Okay, you can take the delta y, you can take the delta x, so you can find out the slope. There will be a value. Okay, suppose that value is x, or suppose that value is m. So now m equal to minus A upon R, and R, you know, it is the universal gas constant. Put the formula, put the value, multiply it with it, and change the sign, you will get the activation energy. So what will happen? Which graph you can draw? You can do it ln K, or you can also do it log K. Okay, you can do the log K. I am not going to complain about it. So log K versus 1 by T. This is the graph you have to draw. Okay, so if it is log K, you just have to do everything. You can take the logarithm na? Instead of ln, you can take the logarithm. That is not a big, nothing will change. Nothing will change. It will be log, it will be log. It's, everything else will be same. Okay, so these two questions are also solved now. Now we will go to the next questions. Okay, I'm solving it a little faster because I want to keep it a small video. Okay, so let's, there are two more good numericals. We will do it and we will finish it. Okay. Thank you. Let me come back. So the last two questions, let's finish it off. Okay. The first question, the visibility is little low. Let me read the question. It is saying that the rate constant for the first order decomposition of a certain reaction is given by this one. It is asking you to calculate the energy of activation, the rate constant at 500 Kelvin, and it is also asking for the temperature at which the half-life period will be 256 minutes. We are not concerned about half-life in this particular video. I'll make another video regarding the rate constant, how to find out the rate constant and how to determine the half-life and all. I'll do that. Then we will discuss this again. Okay, so this is a very simple question. There is nothing so difficult about it. This is kind of a comparing question. This is from IDG 1997. Okay. You all know that ln k is nothing but what is ln a minus EA upon RT. Okay. And they have given you ln k equal to 14.34 minus 1.25 into 10 to the power 4 by T. Alright. They have given it. I am just concerned. Okay, you just have to compare, na? You just have to compare both of them. So ln a will be nothing but it will be 14.34. Okay. Now this EA upon R is nothing but 1.25 into 10 to the power 4. Okay. So now you can find out EA. What is EA? 1.25 into 10 to the power 4 into 8.314. This is the universal gas constant. Alright. So you can determine the activation energy just by comparing with the equation. This is a comparing type of questions. Okay, see different type of questions I am trying to solve so that you can get an idea how to approach all the type of questions. Okay, I think after these 6-7 questions you will be very comfortable with rest of the questions because they are just modifying those questions only. Okay, so now let's come to the second part of this question. It is also asking you to find out the rate constant at 500 degree, 500 Kelvin. It's not degree Kelvin, it's only Kelvin. Okay. So you already have a formula they have given you. You don't have to think about anything else. Just in place of the temperature, they have asked you to find out at 500 Kelvin. They have given you a temperature. They have kept only this unknown. K also they have kept, but that's not a. They have asked the K and there were two unknowns. They have asked one, they have given one. You just have to put it. Just put 500. That's it. Khatam. Do the calculation. I'm not going to do the calculation. You can, if you do not have the access to anti-log table, you can do this also with logarithm. You can just take log k and you can just multiply. You can divide both the side. You can divide both of them with 2.303. You know the calculation. I'm not going to do the calculation because I want you to do, because there you have to do, you have to use your hand, you have to use your brain. So try to calculate. Okay, what is the answer? Actually I have the answer. I think I can give you the answer so that you can check it later. Yeah, I have the answer. The k will be, because I have already solved it, so you can reconfirm. Okay, you can recheck with my answer. K is nothing but 2.35 into 10 to the power minus 5 second inverse. This is the value we are going to get for K. Okay, so try to solve it and do the calculation properly. So let me come to the last question for today. And this is also a very important question. This is actually a very important question. Okay. Sometimes you may not be able to just think, because see, stipulated time, sometimes some external pressure might work. So I should do this question. At least you should know how to approach this question. What is it asking? This is the question. Okay. This is one question. This is another question. It is asking that the rate constant, the activation energy, and the Arrhenius parameter of a chemical reaction at 25 degree centigrade are this. Okay. Let's see what are they given. First thing is temperature. Temperature is given at 25 degrees centigrade. That is equal to 298 Kelvin. Alright, 298 Kelvin. That's it. What is asking? rate constant K is equal to 3 into 10 to the power minus 4 second inverse. Then the activation energy. So EA is nothing but 104.4 kilojoule per mole. Then the Arrhenius parameter is 6 into 10 to the power 14 second inverse, okay, respectively. It is asking you what is the K at T is equal to, that means T tends to infinity, when T is equal to infinite. Okay, and let's assume this is T1. So this will be K1. Let's assume this is T2. This will be K2. Simple, because they have already given T1 at one particular temperature. They have given you a rate constant. They have asked at another temperature what will be the K2, and that temperature is infinite. But infinite means very high temperature, very high temperature. So it's not practically possible, but in theoretically it's possible. So we have to calculate. This is from IIT 1996. Very easy. Nothing is there. Just direct formula. Direct formula. What is the formula? ln K2 upon K1 equal to EA upon R T2 minus T1. Sorry, don't take T2 minus T1 here, because you will understand. Just take 1 by T1 minus 1 by T2. Alright. So what will happen? Just put the values. ln K2, you have to find K1, they have given you. Okay, I won't do the calculation. You have to do the calculation. 104 into 4 kilojoule per mole means 10 to the power 3. You have to convert it into joule. Okay, because the gas constant you are taking in joule per mole. Okay, so you have to convert it into joule. So you have to multiply 10 to the power 3. So 8.314. So 1 by T1 is 298 and 1 by T2 is infinite. Let me check it is visible or not. No, it's not visible. I am hiding it. I need some space, so I have to, okay, I can write here also. I can write here. So ln K2 upon 3 into 10 to the power minus 4 is nothing but, this is in a bracket, 104.4 10 to the power 3 upon 8 into 314. So this is 1 by, I can't write there also because there is no, there is some space I can write. So 1 by 298 minus 1 by infinite, because T2 is infinite. Is it showing? Yeah, almost. Let me erase a little so that I can explain. So what is 1 by infinite? What is the value of 1 by infinite? 1 by infinite is 0. You should know that. Something divided by infinite is 0. Anything divided by infinite is 0. So what can we say? This term is nothing but 104.4 by 8 314 into 10 to the power 3 is 1 by 198 minus 0. So this will be, so the entire equation will be, the final equation is nothing but ln K2 by 3 into 10 to the power minus 4 is equal to 104.4 into 10 to the power 3, 8.314, 1 by 298. You have to solve. I am just making one extra step for you, that is, this is 3 into 10 to the power minus 4 equal to, this is, okay, this part. You can also simplify it using log. You can take log, you know how to take log. 3 into 10 to the power minus 4. So you have to, everything divided by 2.303. Alright, everything divided by 2.303. So I'm not going to do the calculation. It is also not visible. My photo is there. You have to divide 2.303 by to all of the values. Okay, whatever value it is coming, you have to divide 2.303 if you are considering log. Okay, so try to solve it. I'm going to tell you the answer. You will find K2 as this one. Okay, this is the correct answer. 6 into 10 to the power 14 second inverse. This is the correct answer. B. So try to find out the try to solve it. Okay, you have to do the calculation. Don't leave it. Okay, you just find out and match with that particular equation. Okay, so I tried to explain how much it was possible as much as possible, and also I tried to solve few questions so that you can uh, get an idea about so that you can also get an idea about what are the types of questions they might ask you. So I hope this video was helpful for you. So if you have any doubt, you can just mail me. We have the mail ID in the description box, and you can also send a comment. You can also ask in the comment box. I'll definitely respond. So thank you for watching. Like the video, share it with your friends, and subscribe. And thank you for watching. Thanks a lot.